Hello, grade 11s, and welcome to the second segment, rather, of circle geometry 1. So I modified that from the Via Africa study guide, so please take them down. My mistake. Oh, what am I doing? So number 1 states, in the circle with center O below, A, B, and C are points on the circumference. Here's A, here's B, and here's C. OA is 6 square root of 3 units. A angle OB is 120 degrees. And A angle OC is 90 degrees. Calculate OB. You know that O is the center, and B is a point on the circumference of the circle. And we are given that OA is 6 square root of 3 units, so OB is equal to OA. What is the reason for this? They are both radii or radiuses, right? So it means OB is 6 square root of 3 units. Remember, the exam always states that your final answer is 2 decimal places unless specified. So OB is 10,39 units. B angle OC or BOC. So we need this angle. So it's going to be B angle OC plus A angle OB plus A angle OC is equal to 360 degrees. And what's the reason? Angles around a point. I hope that makes sense. B angle OC plus, what's A angle OB? 120 degrees. Plus, what's A angle OC? 90 degrees is equal to 360 degrees, sorry. So B angle OC is 360 degrees minus, what's 120 plus 90 to 10. BOC is 150 degrees. I hope that makes sense. Now we need to calculate AB. So we need to calculate this line. We have this angle, we have this side, we have this side, OB. We'll take 6 square root of 3. Now remember, when you have two sides and an included angle, what do you use? The cosine rule. So it's going to be AB squared is equal to OA squared plus OB squared minus 2 times OA times OB times cos. What is the included angle? A angle OB. Cos AOB. Forgive me for the lack of space there. And what is the reason? Cosine rule. So AB squared is equal to, what's OA? 6 square root of 3 squared plus, what is OB? 6 square root of 3 squared minus 2, 6 square root of 3, 6 square root of 3 times cos A angle OB cos 120. 6 square root of 3 squared plus 6 square root of 3 squared minus 2 324. So AB is square root of 324. AB is 18 units. I hope that makes sense. Now 1.4 states we need to calculate the perimeter of triangle ABO. So the perimeter of triangle ABO. So perimeter of triangle ABO is AB plus OA plus OB. What's AB? 18 plus OA, 6 square root of 3. Plus what's OB? 6 square root of 3. So we get 18 plus 12 square root of 3, which is 38,78 460969. Therefore, perimeter of triangle ABO is 38,78 units. Give me, I hope that makes sense. 1.5, we need to calculate OC. This OC, you can see that OC is also a radius. OC is equal to OA. They are both radii. OC is 6 square root of 3 units. So OC is 10,39. Yes, 10,39. Now we need to calculate AC. So from here to here. Let's see if we have space here. Okay, we don't have space. Forgive me. So AC, we have OA and we have OC. So AC squared is equal to OA squared plus OC squared. And what's the reason for this? Pythagoras theorem. AC squared is, what is OA? 6 square root of 3 squared plus, what is OC? 6 square root of 3. $216. So AC square root of 216 is 14.6969 3846. Two decimal digits, 14.66 significance of 14.70 units. I hope that makes sense. I hope that wasn't too hard. I hope you can see my handwriting too. Now we need to calculate the area of triangle BCO. So we need to calculate the area of triangle BCO. This side times sine this. So area triangle BCO is half times BCO. So OB times OC times sine. That is the included angle B angle CO. Which is half times what? OB. Where is it? 6 square root of 3 times OC is also 6 square root of 3 times sine. B angle CO, we calculated it. Oh, wait a minute. B angle OC rather. Sorry, I made a mistake. It's 150. Here it should be sine B angle OC. So 150 degrees. Hmm. 27 square units. Okay, I hope that makes sense. Then we need to calculate BC. Oh my. Wow. BC. Once more, BC squared is equal to BC squared, OB squared plus OC squared minus 2 times OB times OC times cos. What is the included angle? It's B angle C, B angle OC. What's OB? 6 square root of 3 squared plus what's OC? 6 square root of 3 squared minus 2. 6 square root of 3. 6 square root of 3 times cos 150 degrees. Okay, we get 403.0614 872 BC, the square root of 0763 9129. 2 decimal digits. BC is 20,08 units. I hope that wasn't too hard. Please grin and bear with it. Number 2 states, in the circle with center O below, OK is equal to 100 units and chord GH is 192 units. Here's GH, 192. And then on the diagram it is indicated that GI is equal to IH. So remember the perpendicular bisector theorem. A line segment from the center of a circle that bisects a chord is perpendicular to that chord. So this is 90 degrees. Now let's just determine the length of OH. So OH is a radius like OK. They're both radii. So therefore OH is also 100 units. Now we need to find OI. We have OH, we need to find OI. IH. So IH have GH. And we are given. So IH is half of 192, 96 units. Then OI squared plus IH squared is equal to OH squared. This is the Pythagoras theorem. OI squared plus what's IH? 96. What's OH? 100. OI squared is equal to 100 squared minus 96 squared. OI is square root of 100 squared minus 96 squared. So OI is 28 units. Now we need to calculate IJ. So IJ. So OI plus IJ is OJ. Right? What's OI? 28 plus IJ. OJ is also a radius, so it is 100. IJ is 100 minus 28. IJ is 72 units. Now we need to calculate HJ. Okay, HJ. We have IJ and then we have IH, which is 96. And don't forget, if this is 90, this is also 90. So HJ squared is equal to IJ squared plus IH squared. The reason for this is the Pythagoras theorem. So HJ squared is, what's IJ? 72 squared plus, what's IH? 96. HJ is square root of 72 squared plus 96 squared. 120 units. Okay, I hope that made sense. I hope that wasn't too hard. I know that I misled you by claiming that this is only circle geometry and you used the cosine rule and area rule, but there can be some overlap. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.